All right, students, I'm going to give you 4 examples here. The first one, you can see you have reflections. Remember, little r stands for reflection. This is function notation. This right here means following. So this means reflect over the line y equals x following a reflection over the line x equals 1. So that means we go right to left. This one is first, this one is second. That's what following means in English. Okay, so we have a segment, 2, -4, 2, -4, there's A, and 4, -3, 4, -3, there's B. Okay, it says reflector line x equals 1. So let's go ahead and, you need to know from Algebra 1, x equals 1 is a vertical line. You did it in pre-algebra as well, so you've done it for the last 2 years at least. And reflections are always at 90 degrees to the line and the same distance away. So 90 degrees is horizontal and it's 1 away, so I go 1 away on this side. So there becomes A prime. B is how far away from the line? 3, so I have to go 3 over to this side right here. And there's B prime. So there was that segment, now I have it right there. Now it says to go ahead and that's B prime. Remember, with no primes on it, that means that's the pre-image. 1 prime, that means that's the first image, and we're doing 2, so the next one will be B and A double prime. Now it says reflect over the line y equals x. That's the one we're doing now. Now, from your notes from the original video, you know, or should know now, in the notes I've given you, that a reflection over the line y equals x, the original xy, becomes yx. All you do is switch the coordinates. So what I suggest you do prior to actually plotting them here is actually write out A prime and put the coordinates. That is 0, 1, 2, 3, 4, 0, -4. Okay, B prime is -2, -3. Now I can just do A prime, double prime. Remember, it means to switch the coordinates. So that becomes -4, 0. It's much easier to do them anytime you can by the numbers first and then plot them. And my -2, -3 becomes -3, -2. So -4, 0, let's go ahead and change the color for that one again. -4, 0, 1, 2, 3, 4, -4, 0. That is A double prime. Okay, and -3, -2 is right there. B double prime. And then I go ahead and connect those, and there's my final image. Okay. All right, so sometimes you're only doing a single reflection. I did 2, so you got 2 and 1. So I'm just saving time instead of doing 2 separate ones. Just do 2 reflections and 1 problem here. Okay, but this is the type of stuff I want to see when it's a reflection over the x-axis or the y-axis, or over the line y equals x or y equals -x. I want you to use the rules and write them down on paper first and then plot them. All right, translation. So that was reflection. Little r means reflection. Okay, translation rule. You got to memorize this because you're going to have to write it out, a translation rule on the test. Okay, translation rule is always x, y, x, y maps onto. It's called maps onto. That's what the arrow is here. X plus 3, y minus 3. So this is your ability to count. So I plot -3, 5. 1, 2, 3, 1, 2, 3, 4, 5. -3, 5. A. Remember, no prime because that's the pre-image. And all it says, remember the x direction is left or right, right? So that is right 3. And y is up or down since it's negative. That'd be down 3. Down 3. So I just count. Can I count? If you can't count, you got to send you back to elementary school. 1, 2, 3, 1, 2, 3. There's A prime. That's simple. Now I could have also just plugged the point in, -3 in for the x right there. -3 plus 3 is 0. Notice this point is 0, 2. And so there's my 0, and I could have plugged the 5 into the y and done that. 5 minus 3 is 2. And you see your 2 right there. So you can also just plug it in, and you get it right there. Okay, so that's called a translation rule. So if it ever asks you to write a translation rule, this is what a translation rule looks like. It better start with x, y, an arrow, and you pronounce that maps onto, and then either x plus or minus some number and y plus or minus some number, depending on what direction you're moving. Okay, next, we're doing rotations. This is about a point off the origin. This is about the origin. We'll do the origin first. Now, there's a rule. Notice this is also a reflection. First off, you should know x equals 0. The line x equals 0 is the same as the y-axis. Okay, if I reflect over the y-axis, that switches the x-coordinate, so it becomes negative xy. Okay, so I can actually do this straight out by numbers if I wanted to begin with. So a equals -3, -1. A prime, since that's a nice one that works, it's negative xy. That becomes 3, -1. Okay, applying this, it's right there. And then we're rotating it -90 degrees. Well, -90 degrees is first a reflection over the y-axis and then over the line y equals x. So here we just did the y-axis, it switches the x-coordinate, and then so xy becomes negative on the x-coordinate, and then over the line y equals negative x, switches the x and the y coordinates. So this is a rotation of -90 degrees. So this is doing it by the points themselves. So now I apply that to this here, and so a double prime, y is -1, and negative x would be -3. Okay, so there's my final answer right there. Okay, and you have these from your notes, these two rules. Okay, and that's because it's about the origin. Well, now I'm going to also show you, after I reflect it over the y-axis, so we got to 3, -1. 3, -1. Okay, there's A prime. And it says to rotate at -90 degrees. Negative degrees is clockwise. So if this is quadrant 4, remember each quadrant moving from one quadrant to the other is 90 degrees. So I'm in quadrant 4 now, going clockwise, so I'm going to put in quadrant 3. So my answer is going to be somewhere in this quadrant. That's -90 degrees. If it's positive 90 degrees, I put it up here in quadrant 1. That's positive 90, this would be -90 degrees if you're starting in quadrant 4. Okay, so just know that. Let me go ahead and take those off. Okay, so another way, if you didn't want about rotations, this is for rotations, not the reflection. Reflection, you have to just do it as you do it. You could have plotted the y-axis and counted across. That -3, -1 right there, reflecting over the y-axis, puts it over here at 3, -1. So you could have done that if you didn't have the rule memorized of -xy. But for rotations, I can always go ahead, let me change the color here. It's about the origin. So there's my center of rotation. I draw a horizontal segment out from there and down, in this case, to get to that point. And I'm rotating -90 degrees. So this horizontal has to become vertical. I'm going clockwise, that's -90 degrees. What is that distance? 1, 2, 3. What is this distance? 1. So I'm now rotating it, and it stays the same. Change the color now. So this 3, 1, 2, 3, and then the 1 was in front of it. It's rotated, that 1 stays in front, So it stays in front, and so there's my answer right there. -3, and then forward 1. Okay, so there's that answer. A double prime. And what's that point? -1, -3, just like we see it right there. -1, -3. Okay, now I'm going to do that same one with it again. See, when it's about the origin, I don't have to do the triangle or the, this horizontal and vertical here and rotate that way. I can just use the rule as we just did over here to begin with, because that's about the origin. But when it's off the origin, as this one is here, I have to. Now, rotation of 270 is the same as a rotation of -90. Okay, you have that on your notes already. Okay, but now it's not about the origin, so I can't use this y negative x rule. That's only about the origin. It's about the point 1, 3, and this is -3, -1 right there. Okay, so again, I'm going to go ahead and draw a horizontal out from the center of rotation, which is 1, 3, and then down until I get to the point, the pre-image point. Okay, now what you do is -90 degrees. Think of it in terms of -90. What direction is that? Clockwise. So this distance of 1, 2, 3, 4 is now going from horizontal to vertical. We're going clockwise. And this distance is 1, 2, 3, 4. So this comes up 4, 1, 2, 3, 4, and then don't forget this is trailing it back here. When I rotate this to the right, that is from behind. It's still behind it, so I have to go back 1, 2, 3, 4, and that right there is my answer. A prime. Okay, so now what is that point? -1, 2, 3, 1, 2, 3, 4, 5, 6, 7. -3, 7 would be my answer. Okay, now how can I check to make sure I've got it right? Well, if I take a segment, can I connect from the pre-image to the center of rotation, and from the center of rotation to my image point? Okay, I should see a right angle. Okay, and that's pretty darn close. 1, 2, 3, 4. Yep. 1, 2, 3, 4. Yes. 1, 2, 3, 4. 1, 2, 3, 4. Yes. So this right here is a 90-degree angle. I want to let it pass the mark there, but that's close enough. It's a 90-degree angle, and that's how I can tell that I did rotate it 90 degrees. So now the question is, did I do it in the right direction? You got to remember -90 is clockwise. On the DCAS, remember, as I've told you, they will say rotate 90 degrees clockwise or rotate 90 degrees counterclockwise. They won't use the positive -90. They'll say clockwise and counterclockwise. So you do have to know your directions of clockwise and counterclockwise. Okay, that goes ahead and explains your key types. So we have a point about off the origin. I have to rotate, and I have to use that method. But in 12, I went ahead and showed you both methods with the triangles themselves, if you want to think of it that way, and just using the rule of y negative x for rotation of -90 degrees.